This is your lesson on arithmetic and geometric sequences. It's actually going to follow the notes of Glencoe 11.1 and 11.3. Looking at our first example, we're just looking at to find the next four terms of an arithmetic sequence. So it's important to figure out how am I going from one term to the next. How do I go from 55 to 49? How do I go from 49 to 43? Well, all you need to do is figure out what's the difference between these numbers. Well, the difference between 55 and 49 is a difference of 6. Now, we're not adding 6, we're going to be subtracting 6 to get from one term to the next term. This is going to be our common difference. So then, to find the next four terms, I'm going to take 43 and I'm going to subtract 6 from him. 43 minus 6 gets me 37. 37 minus 6 gets me 31. 31 minus 6 gets me 25, and then 25 minus 19 gets me, 25 minus 6 gets me 19. These are the next four terms. All right, so now in example 2, I'm referred to the information provided, and then I'm supposed to assume that it's going to be an arithmetic sequence that's going to continue, and I'm supposed to figure out how much would it cost to rent the crane for 12 months. All right, well, some information has been provided to us. For example, we have been provided our A1, or our initial amount, our initial cost. Our A1 is going to be $75,000. The next thing that we can figure out is our common difference. How do we go from one term to the next? How do I go from $75,000 to $90,000? Well, I simply added $15,000. Okay? So that's my common difference. Now I'm going to plug this into the formula to find the nth term. Okay, so here's my first stopping point. Specifically, the term that I'm going to be looking to find will be my 12th term. So I'm just going to search for A12. And I'm going to plug in my A1. My n value here is going to be 12 because I'm looking for the 12th term. And my common difference is 15,000. Now I'm going to follow order of operations. First, I'm going to work inside my parentheses. 12 minus 1 is 11. Still going to multiply that by 15,000. So now we're at a point where we can just type this into our calculator, and we're going to get $240,000 is the cost of renting the crane for 12 months. Looking at example 3, whenever I'm asked to write an equation for the nth term, I'm basically being asked to plug the information that I know into our formula and then simplify. So I'm quickly going to first rewrite all my information, and then I'm going to identify my A1. My A1 is going to be 8 because this is my first term here, okay? Having this quantity n minus 1, n's kind of just like having an x in your equation. It's something you need to have. The common difference, that's going to be how do we get from 8 to 17? 8 plus what is 17? Well, that means our common difference is going to be 9 because I'm adding 9 to each of my terms, okay? So now I'm going to simplify my expression. I'm going to distribute my 9. So we get a 9n minus 9. Then I'm going to combine 8 and negative 9, leaving me with an equation of negative 1 plus 9n. This will find any term of the sequence that I'm asked to find. All right, in our next example, well, our last example for arithmetic sequences, I'm going to explain the method done by the textbook, but I'm really hoping that you take to heart this alternate method. It takes more of a logic approach. It's just one that I would personally be a little bit more comfortable to use. All right, so I'm finding the four arithmetic means between 16 and 91. So if there are four terms between these, that tells me that, well, 16 is my A1, and 91, this is going to represent our, this is first, second, third, fourth, fifth. He's representing our sixth term, okay? So now we can use our equation of AN equals A1 plus n minus 1 to first figure out what my common difference is. So my nth term, let's let 91 be our nth term. 16, that's going to be our A1. We don't know, well, we do know what our n is. Our n is 6, but we don't know what the common difference is. Okay. So now let's just subtract 16 from both sides. And so then 91 minus 16 gets me 75. And then 6 minus 1 gets me 5, so we have 5 times our common difference. Now we just need to divide both sides by 5. And so then we get that our common difference is 75 divided by 5, which is just 15. So we just need to add 15 from one term to the next. So 16 plus 15 gets me 31. 31 plus 15 gets me 46. 46 plus 15 gets me 61, and 61 plus 15 gets me 76. Once again, please make sure you're looking at this alternate method, which is just a more logical approach. We're now looking at the examples found in 11.3, which is going to introduce the concept of geometric sequences. We're told to find the missing term in this geometric sequence. So we first need to figure out what are we multiplying by to get from one term to the next. How do we get from 8 to 20? How do we get from 20 to 50? Well, to figure out what we're multiplying by, I'm going to take my second term of 20 and divide it by 8. That's going to get me a common ratio of 2.5. You should check to make sure that this is going to be the same thing to get from one to the next. So 20 times 2.5, that's going to equal 50. That's how we know it's going to remain consistent. So to find the next term, I'm going to take 125 and I'm just going to multiply that by 2.5, and then I'm going to get the answer of 312.5. All right, let's look at example 2 where we're finding a particular term. We're finding the 8th term of a geometric sequence given our common ratio in our first term. So once again, let's just write out our everyday example of our equation. So an, or our nth term, is equal to a1 times our common ratio raised to the power of n minus 1. So we're going to plug in a1 is -3, common ratio -2, and the term we're trying to find is the 8th term. So our value for n is going to be 8. So we need to remember our order of operations here. First, looking in the exponents, we're dealing with to the 7th power. So now I need to next do -2. That quantity raised to the 7th power is going to get me -128. Then lastly, -3 times -128 gets me 384. All right, now we're going to write an equation for the nth term given a couple parts of the sequence. Once again, I'm just going to write down my general equation here, just to give me some frame of reference. First term is going to be 3. Next thing I need to do is figure out 3 times what gets me 12. My common ratio, 3 times 4. 4 is my common ratio to the power of n minus 1. Notice we cannot simplify this any further. We have a base of 3 and a base of 4. They're not common bases, that's why we cannot simplify this. 2 more examples. In this next one, example 4, we're to find the 10th term given the 4th term in the common ratio. Notice the piece of information we're missing is our a1 term, so we first need to find him. So I'm just going to write out my general equation, frame of reference for myself. We're going to use our 4th term, okay, which is 108, and we're going to set this equal to a1 times 3 to the power of, n is going to be 4 minus 1, okay? So then we have 3 to the power of 3 is equal to 108. 108 is equal to a1. 3 to the 3rd power is equal to 27. So I'm now going to divide both sides by 27. And 108 divided by 27 gets me an a1 term of 4. So now all I got to do is fill in that missing information to my general equation. We have 4 times 3 to the power of n minus 1. We are now going to plug in a value for n because we're specifically told to find the 10th term. So if we're looking for the 10th term, my n value is 10. So we're really going to be dealing with 4 times 3 to the power of 9. Okay, so 3 to the power of 9 is a really big number, so let's just automatically multiply that by 4. 4 times 3 to the 9th power, type it into your calculator, you get 78,732, and here's our 10th term. All right, last example, we're finding arithmetic means. Once again, I do ask you, please look at the alternate method it does take a little bit more of a logical approach. All right, so if we're given 2.25, we need to find 3 terms between him. We're given our first term, and we're given here, this is the first, second, third, fourth, our fifth term. Oops, I had already written that, given it away. So let's plug in what we do know to figure out what we don't know. We do not know our common ratio. So here's my general equation. And I'm going to use my nth term being 576. He's going to be our fifth term. So we have 2.25. Don't know our common ratio. And it's going to be raised to the power of 5 minus 1, which will reduce, I'll reduce it now, to the power of 4. We're first going to divide both sides by 2.25. And when I divide that 576 by 2.25, I get 256. And that's now going to be equal to r to the 4th power. Next thing I'm going to do is I'm going to take the 4th root of both sides. Now, whenever you take an even index, the even indice root of both sides, you're going to end up with a positive or a negative answer. The 4th root of 256 is 4, so that is our common ratio. Another reason to logically think about why our common ratio could be 4 is because we're given our first and our fifth term. We don't know whether the even spots are going to be positive or negative. We just don't have enough information here. So I'm going to multiply 2.25 by 4, and I'm going to obtain the answer of 9. Now he could be positive or he could be negative. Then I'm going to take 9 and multiply him by 4, and he is going to be the answer of 36. Now, regardless of what he is, he has to be positive because our odd-termed numbers in the sequence have to be positive. So then our even term is positive or negative. 36 times 4 gets me 144. That's a terrible 4.